Hey guys, so yeah, I know my last video project, I said I was done with projects and I needed to get to track work, which I do. But I just came up with something and I wanted to test it out, and I thought, one more project, just one more. So this one was inspired by Tom from Tom's Trains and Things, and before I started the project, I reached out and I consulted Tom, our resident electronics expert, and he gave me some direction and some clues on what I would need for this project. So I just wanted to give him a quick thumbs up and a shout out. Thank you, Tom. Appreciate all your help. Let me get you down here to the workbench and I'll show you exactly what I am working with. Okay, so what do I have here on the bench besides a bunch of junk? Well, I got a couple things. Start out very simply. This project is going to entail powering up this IP camera. It's made by a company called Amcrest. It's palm-sized almost. You can plug it up via an Ethernet cable. It is also Wi-Fi enabled, so you can configure this to your Wi-Fi network. It's got a very small pin in there for your power, 5 volts. So I am looking to put a couple of these in my train room. And the problem is, where I want to put them, I don't necessarily have power, and I don't want to go running a whole bunch of electrical wire back to my panel, my electrical panel, to put in outlets to plug these in, because these things come with a power cord. Again, it has that little tiny plug on the end, which comes out to a USB plug here, and then it has your standard USB to AC power adapter. So typically you would install this somewhere near where you have an outlet so that you can plug it in. Now, the cable that they give you is 10 feet long, so you do have a lot of length. But again, if I want to put one of these in my ceiling, I don't want to have to go and run electric in my ceiling just to put in an outlet box to plug this in. When I reached out to Tom, I told Tom that I have this old power supply here that came from an old computer. It does put out, it's rated at 240 watts of power. What does that mean? Well, it has an output of 12 volts. So 12 volts comes out of these power leads. There's actually 2 of them. There's 2 sets of them. The first one here will actually put out 16 amps of current. The other set will actually put out 16.5 amps of current. So together, you multiply those up, add them together, you get 240 watts of power. Well, what does that mean for me? Well, these things only require 5 volts. So I've got plenty of that with a 12 volt power supply. I should be able to hook up several of these with no problem. So then we turn to the current. Well, these only take up a maximum of 2 amps. So that means I could probably hook up at least 8 to this power supply, being that it's putting out 16 amps on one output. I don't think I'll be running 8. I'm looking at maybe a max of 4. So this should give me ample enough current and voltage to do that. So what do we need to get this project started? Well, we need a couple tools. You're going to need your standard pliers, wire cutters, wire strippers, your little needle nose pliers to hold these small thin wires we're going to work with, a very small flat screwdriver, your soldering iron, and a voltmeter so that we can test voltage. The other thing that you're going to need, and this is where Tom clued me in, are one of these guys. So let me explain what these are. These are called buck converters. They convert DC power down from one voltage to a lower voltage or possibly a higher voltage. They're also known as step-down converters. This particular one here, Tom clued me in on and said, hey, you would be able to run a bunch of cameras off of this one because you've got your input here, which is where your 12 volts would go. There's a potentiometer here is where you would adjust the voltage that comes out of the end over here. And this particular buck converter will take up to 8 amps. So essentially that would give me 4 cameras. But then what that means is I have to plug this into here and then run 4 separate cables out of here to where these various cameras are going to go. And that might not be the most ideal situation. Also, putting 4 cameras on here puts it at the max of 8 amps. And I certainly don't want to blow this out or cause a fire. I do believe it has a shutdown mechanism inside. So if it does start to overheat or reach its limit, it does shut down on its own. But I would rather not get there. So let's set that aside. I'll use this for a different project later. These here are basically a smaller version of that. These don't have the screw down terminals like the other one does. So I would need to solder directly onto this board. Here is your input, your positive and your negative. That's where your 12 volts will go. Out here is where your output would go to your device. And your potentiometer here with that little screw that you turn to adjust the voltage that comes out. It also comes with this little heat sink that I'm guessing sits on top of that little device there. I'm not 100% sure what that is. I'm going to guess and say it's a MOSFET, but don't quote me on that. Tom will probably correct me if I'm wrong. But this thing is what's going to heat up. That's what's changing the current. And that would be its heat sink to cool it back down. So this particular device will handle 12 volts and it will go up to 5 amps. So I should be able to power 2 cameras on this safely without reaching its limit. But honestly, these things were so cheap. I spent $11 on this on Amazon, and I think I spent probably $9 on 4 of these. So for the price at $2 $2.50 a piece, I don't mind just using 1 per camera. So that means I can take my wires from here, plug this guy into its outlet, run a straight 12 volt cable, whatever distance I need, and then tack this onto the end of it, and then have the camera right behind it. That's giving me enough voltage down the line that I won't get a voltage drop if that occurs with distance. And also, if I ever need to tap into this to use it for something else, if I have the current and the voltage left, I can do so. Whereas if I put this guy directly on the end, I'm already dumbing that down to 5 volts, and then if I run my cables out, I only have 5 volts through that bus. So I think this is going to be the best way. So how do we get this started? Well, let's talk a little bit about the power supply. So the power supply has your standard plug that comes with a computer, and you plug it in, but there's no power. I can't hear the fan running. I don't see the power light on. Something's wrong. Well, if you notice, when these things are plugged into a computer, into a motherboard on a computer, on your computer, you've got a power button. We don't have that here. There is a button on the back here which allows you to press that, and you do get a green light, but this is only to test to make sure that the power supply is functional. This button is telling you that you're getting current in, that current is at the right voltage, the heat temperature is right, everything is all green, good to go. But when I let go of that, I'm now left with no power. So I can't certainly sit there and hold that all day, because that just wouldn't be cool. So I learned a long, long time ago in my IT training The power cord, you've got a bunch of different cables here that are hooked into this jumper, and several of them do several different things. What I'm concerned with here is a green wire and a black wire. So there are several black wires here that are your negative output. They're your grounds. What I'm concerned with is this green wire. This green wire is actually hooked to the power button, which would go onto your computer. So I don't have a power button right now, and I didn't plan on using one. I was just going to leave this plugged in all the time and use it that way. But you certainly could cut these two lines, put a switch on there, and have a toggle back and forth or something to actually turn these on and off. I'm going to keep my cameras running all the time, so there was no point in doing a switch. So all I need to do is jump that green cable to the black cable. Now again, you could cut these, splice them, and put them together and solder them. I'm not going to do that either. I'm going to keep this plug intact. But what I am going to do is jump a couple wires here. So I'm going to find out where one of these blacks go, and I know that there are two right there. I'm just going to take a standard 18 gauge wire. I'm going to shove it into one of those holes to make contact. And then over here on the other side, I can see that my green plug is this very first pin. So when I plug that in there, now you'll see when I flip this up, I get a green light. Not only do I get a green light, but if I put a voltmeter on the ends of these plugs here, one on the black and one on the yellow, you see I get 12 volts. So I know I'm getting constant power. Now, if I pull this cable back out and I do that same test and go back to the black and back to there, I get nothing. So that's how I know I'm in a safe territory if that guy is removed. Essentially, that's my safety switch. Now we need to work with this guy. So the first thing that I want to do is get this thing set up to where I know the voltage is correct. And I got some alligator clips here. So I'm going to take this cable here. I'm going to hook one to black. And I'm going to hook the other to the yellow. And I know the yellow is my positive, so on the board here I'm going to go positive in. And we're just going to clip right there. And I'm actually going to bring in some of my helping hands here to hold this board steady for me. And oops, falling off there. We're going to put our negative on, and we get a red light telling us that it's on. So let's get this turned back on. And I'm going to take my negative and put it to the negative out. And I'm going to put my positive to the positive out. And right now it's reading 10.5 volts. And that's just because the potentiometer may be turned in that direction. So if I use my little screwdriver here and I turn that screw, you'll notice that the voltage is now going up. But we don't need to go up, we need to go down. So I'm going to go on a counterclockwise, and we're going to try and take this thing down to just a little over 5. Alright, I'll take 510. That's fine. Great, so now I'm at the correct voltage. So now I'm going to power everything down, and I'm going to show you how I'm actually going to hook up the camera. Another thing I wanted to show you was, remember that power cord that came with the camera has USB on one end and this little plug on this side. Well, I didn't want to mangle this cable. I didn't want to cut it and splice it just so that I could hook it up to the buck converter. So I wanted to keep this intact just in case I ever wanted to use the camera again. I had the full cable. If I wanted to plug it somewhere else or put it in a place where I did have an outlet, I wanted to keep the cable. So that left me with, I need something to plug that into. So again, went back to our favorite online store, Amazon, and I found this guy. It is basically a female plug, and it's got the pinouts on the back for what you would usually have for those 4 wires that connect in there. You have to check the specifications if you guys get these from some other source, because I thought when I looked at an original schematic diagram, if you notice here on the case, one side is flat and the other side shows you the crease of where they put the shielding case together. I was going off of something that I saw before where that crease was that made this pin 1 and this pin 4. The 2 pins in the middle are your data pins. I'm not using those. I just need positive power and negative power. So I thought that this would be pin 1 and this would be pin 4, and it turned out that when the manufacturers made this case, they put the shielding on upside down, and that means that this is pin 1 and this is pin 4. So that changes my polarity when I'm putting this together. And if I got that wrong, we'll know later when I test it, and I will correct myself. But let's see how we go. So I need to get this soldered onto the output of this. And then it comes with this cute little case that you can put that together and have yourself a little plug. So I'm going to use just a small, short length of wire. I'm going to say that length is probably just fine. Got my wire strippers here. Just need a tad bit off the end. Good enough. Same here. Alright, so I've got my soldering iron all heated up. Take that guy and put him right there for now. And get our little USB guy over here. So I'm going to work this way. And again, like I said, they put the case on this wrong. So for me, this is pin 1, that is pin 4, and we'll go from there. So pin 1 means positive, pin 4 means negative. So that means when I get over here, whichever wire I've got on pin 1 for positive has to go up there, and the negative has to go down there. So let's get to soldering. Just going to prepare this. I'm going to do this 1 second, the actual buck converter. But I might as well prepare it while I'm here. All right. Now with that part done, all we need to do is solder that onto there. And now my pin 1 is down here, which is this orange wire, which is over here. So I need to reverse these, just give them 1/2 turn back, so I can get my output positive over there. Awesome. And there. So we made our connection. Now what I'm going to do is put this guy's cute little case on so that I don't rip any wires out. And these just clip together. There's a couple of register marks in the plastic. And there we go. We've got a 5-volt buck converter. So now let's get it hooked back up. And the way that we can test it is actually by hooking up this cable and making sure that we get 5 volts out of that. Alright. And you can see our buck converter has power to it. Alright, just to make sure that our potentiometer hasn't moved, I want to test the output here on the pads first. So there's our negative, there's our positive. $510, that's good enough for me. Alright, let's put our USB plug in here. There we go. Now, on most plugs, most of these type of connectors, normally the hot is in the center and your ground is the shielding on the outside. So going on that theory, what I'm going to do is take my red lead here, my positive lead, and I'm going to put it in that hole. And I'm going to take my ground pin and I'm going to hold it on the outside of the shielding. And look, we've got a positive 5.10 volts. So what does that tell us, folks? Tells us that the power supply is putting out 12 volts through the cables with our jerry-rig switch. 12 volts is going in there. The potentiometer is doing its job, putting 5 volts out over here into this USB plug. Then the camera plug is transmitting that same voltage to the end here. And now, if I plug in this camera, I should get a red light to tell me that I've got power. Cross your fingers. Do we get a drum roll? Let's see what we got. There's my red light. And if I set this down, you'll notice that it will do a couple spins and it will orient itself. Here's its spin. And from my cell phone here, I'm actually going to pull up the app that comes with the software. And it's probably still booting. And in a couple seconds, we should get a picture. There it is. It's looking at the power supply. And then actually from this app, I can say, spin the camera. Back. And look, there I am. Hi guys, camera to camera view there. So, let's wrap this up. So I'm going to call that a success. So now all I have to do is take that buck converter, keep it with this camera and the USB plug, and wherever I run my 12 volt, let's just say if I decide to install this 12 volt power supply underneath of my layout where there is an outlet to plug that in, I can then run a set of 18 gauge wires back to this buck converter, and then use that to power the camera. And then I should be able to put 3 or 4 around my layout somewhere, and then I'll be able to sit at my command station over here to my right, your left, I believe, and watch trains from my train room while controlling them with JMRI, or my phone, or my wireless throttle. Either way works. But I hope this was a something that you guys might consider at some point. This is all new to me. Again, with Tom's help, I was able to pull it off. I'm not an electronics expert, but I am willing to dabble in and try it out. One day, Tom, I will get to the Arduinos. I promise. Right now, this is as simple as I can get. So I'm going to call this a success. Thank you guys for hanging with me. I promise I will get back to the track work so I can get trains actually running. But for now, thank you, rail riders, and let's ride these rails together. We'll see you.